Hello everyone. So this is the last part of our lesson on the basic differentiation rules. So here we will be discussing the derivative of exponential and trigonometric functions. So malalaman natin dito kung ano yung derivative ng six trigonometric functions at yung natural exponential function. Okay, so to start, let us have first the derivative of the trigonometric functions. So we have here the following formulas. So since we have six trigonometric functions, anim rin yung formulas natin. So the first one, we have the derivative of sine x is equal to cosine x. So just remember that one. The second one, the derivative of cosine is negative sine x. The derivative of tangent x is secant squared x. The derivative of cotangent x is negative cosecant squared x. The derivative of secant x is equal to secant x tangent x. And the derivative of cosecant x is equal to negative cosecant x cotangent x. So, ito yung anim na formulas or derivatives ng trigonometric functions. So, just remember the following formulas. Example, let's apply these formulas. We have f of x equal to x cosine x minus 2 tangent x. So here, we will still apply the basic differentiation rules na na-discuss natin sa previous videos natin. So here, since we have minus, so we will apply the sum or difference rule. So the first term is x cosine x. So here, x cosine x, we have two factors. So therefore, in this case, we will apply the product rule. Okay, so we will apply the product rule, so you will let your u be x and v be cosine x. And the second one, 2 tangent x, you will just apply the constant multiple rule. Okay, so you have a numerical coefficient and a function tangent x. So constant multiple rule yung gagamitin natin. So for this one, we will now have f prime of x is equal to, first, we will apply the product rule here. So you will have u dv plus v du. So u is x. So you have x times the derivative of v, which is cosine x, plus v, which is cosine x, times the derivative of u, which is x. Okay, so this is just for the first term. Okay, then minus the second term, we will apply the constant multiple rule. So we will just copy the numerical coefficient, which is 2, times the derivative of the function, which is tangent x. Then let's apply the derivatives of trigonometric functions and the basic derivatives that we have learned from our previous lessons. So we will have, so this will become x. Then derivative of cosine x is negative sine x. So this is negative sine x here. Plus, we have cosine x. Derivative of x is just 1. So this is 1. Minus 2 times derivative of tangent x is secant squared x. So we have secant squared x. So that's it. Then let's simplify. We will have negative x sine x plus cosine x minus 2 secant squared x. And this is now our final answer. Okay, so the same pa rin yung processes na kailangan nating gawin. Okay, so you will always apply the basic differentiation rules. Okay, next we have sine x, cosine x. So here we have two factors. You have sine x and cosine x. So you will treat your sine x as your u and cosine x as your v. So we will apply product rule here. So we will have f prime of x is equal to u dv. So u is sine x times the derivative of v, which is cosine x. Okay, plus v du. So we have cosine x, our v, then du, derivative of sine x. Okay, then let's Simplify, we have sine x. Derivative of cosine x is negative sine x plus cosine x. Derivative of sine x is cosine x. And this is now equal to sine x times negative sine x is negative sine squared x. Then we have plus cosine squared x. And I can rearrange this one. Cosine squared x minus sine squared x. And take note, cosine squared x minus sine squared x is an identity. If you can still recall, cosine 2x is just equal to cosine squared x minus sine squared x. This is one of our lessons in pre-calculus. So please review your trigonometric identities. If you can still express the expression, okay, na magagamit yung mga identities sa trigonometric functions, then please do so para mas simplify natin yung expression natin. And this is now equal to cosine 2x. And this is our final answer. Okay? Now let's try example number 3. We have tangent x over secant x. Okay, so let's differentiate this one. So we will apply the quotient rule. Your u is tangent, your v is secant. Okay, so we have y prime is equal to, quotient rule is v du minus u dv over v squared. So v is secant. So we have secant x times derivative of u, which is tangent x, minus u tangent x, derivative of v. So we have derivative of secant x. All over, we have secant squared x. So you square the denominator. Then after that, let's simplify. We will have secant x times derivative of tangent is secant squared x. Ayun. Minus, we have tangent x. Derivative of secant is secant x tangent x. Yun. All over secant squared x. So there. Then as you can see, secant x is common to both terms here, so we can factor that one. So we will have secant x times. So what's left is secant squared x here. And we have tangent and tangent. So we have tangent squared x all over secant squared x. Now, take note, secant squared x minus tangent squared x is an identity. Now, take note, tangent squared x plus 1 is equal to secant squared x. This is one of the Pythagorean identities. Now, if I'm going to move this tangent squared x to the right hand side of the equation, we will have 1 is equal to secant squared x minus tangent squared x, which is this one. So therefore, secant squared x minus tangent squared x is just equal to 1. So I can replace this one by 1. So we will have secant x times 1 or just secant x na lang. So ito, 1 lang yan. Okay? All over secant squared x. So in this case, we can cancel out 1 secant x. So we have 1 over secant x. And what is 1 over secant? That is the reciprocal of cosine, right? So we have cosine x. So the final answer is just cosine x. So as what I've said, if you can simplify the expression, please do so by applying the identities that we have learned in pre-calculus. Okay? So we have cosine x. And actually, from here, from the given equation, tangent x over secant x is just equal to sine x. if you know the equivalent form of the given expression that is equal to sine x, you can actually differentiate this one easily because we know that the derivative of sine x is cosine x. So you don't need to undergo this process. Okay? So it's up to you if you mastered the identities. Okay? So that's it for the derivatives of trigonometric functions. The last one, the derivative of the natural exponential function, we have here, if f of x is equal to e to the x, then f prime of x is equal to e to the x. So therefore, the derivative of e to the x is itself only. Okay? Example. Yan. Derivative of 4e raised to x. In this case, we have a constant multiple. So the numerical coefficient is 4 and our function is e to the x. So applying the constant multiple rule, f prime of x is now equal to 4 times the derivative of e raised to x. And the derivative of e raised to x is just itself. So the answer will be the same, 4e raised to x. So ganun lang siya. Okay? Number two, we have this one. So here, we will apply the constant multiple rule. Dito naman, we will apply the product rule. Okay, so magpa-product tayo dito. This is your u, si 3x squared, and this is your v. So from that, we will now have y is equal to the derivative of 2e raised to x minus the derivative of 3x squared e raised to x. So again, dito magpa-product tayo sa second. Dito naman magmo-mult as constant multiple rule lang tayo. Okay? So we will now have, let's apply first the product rule, then we will differentiate the given expression ng sabay. So we have the derivative of 2e raised to x. Ayan. Minus, using the product rule, we have u is 3x squared. So we have 3x squared here. Times the derivative of e raised to x. Ayan. Plus e raised to x, our v. Then derivative of u, which is 3x squared. So yon. Then let's simplify. We will now have the derivative of 2e raised to x is constant multiple rule. We have 2 times the derivative of e raised to x is still e raised to x minus we have 3x squared. Derivative of e raised to x is still e raised to x. So we have that one plus e raised to x times derivative of 3x squared is 3 times 2, which is 6, x to the 2 minus 1, or just 6x. Yan. Then let's simplify. We can distribute the negative sign. So we will have 2e raised to x minus 3x squared e raised to x. Then minus, unahin natin si 6x, e raised to x. Then as you can see, e raised to x is common. So we can factor that one. E raised to x times. So we have 2 na lang minus 3x squared. And we have minus 6x. So you can have this one as your final answer. Okay. So for the last one, number 3, let's try this one. Y equal to x e raised to x sine x. So as you can see here, we have 3 factors. We have x, e raised to x, and sine x, or we have 3 functions. But take note, for the product rule, we only need 2 functions. So therefore, we will do something here para magamit natin yung product rule. So ang gagawin natin, we will group the 2 functions, and the third one will be your second factor. So in this case, I will group x e raised to x, then iba, another factor si sine x. So this will become my u, this is my v. Then from that, I can now apply the product rule. Okay? So applying the product rule, I will just erase the writings here. So this is again my u. This is v. So applying the product rule, so we have here y prime is equal to u dv. So you copy x e raised to x times the derivative of v, which is sine x. Ayan. plus v is sine x times the derivative of u, which is x e raised to x. Now, from here, derivative of sine x, madali lang yan. Alam natin yung derivative niya, which is cosine x. But the derivative of x e raised to x, we will again apply the product rule here. Kasi dalawang factors yan. Okay? So, magpa-product rule ulit tayo. So, merong product rule sa loob ng product rule in this case. So, your u here is x, your v is e raised to x. So, we will now have, copy muna natin tong nasa unahan, sin x, ayan, plus sin x times derivative of this one using product rule. So, u dv, so you have x, derivative of e raised to x, which is your v, plus v, which is e raised to x times the derivative of u, which is x. So, that's it. Then we can now simplify. So, we have x e raised to x. Derivative of sine is just cosine. So, we have cosine x plus sine x times, we have x, derivative of e raised to x is e raised to x, plus e raised to x times, derivative of x is 1, so e raised to x na lang yung matitira. Then after that, we can distribute this one. So we will now have x e raised to x cosine x plus x e raised to x sine x, then plus e raised to x sine x. So we distributed sine x. Okay, then after that, as you can see, e raised to x is common, so we can factor out e raised to x. So what's left is x cosine x plus x sine x, and we have sine x. And that is our final answer. Okay, so this ends our lesson on the derivative of exponential and trigonometric functions. Thank you for watching.